Hey, good afternoon, everyone. So this is Ankur. I head operations at Great Learning, and thank you all for taking time and coming and attending this session. So in this session, what I'll do is I've structured it in two parts. In the first part, I'll talk about the overall domain of artificial intelligence and machine learning. How is it evolving? What do we understand when we talk about some of these terms? And yeah, in today's day and age, the kind of use cases that are evolving for artificial intelligence and machine learning are evolving very rapidly. So we'll talk about that, right? And then I'll give you a brief overview of what does it mean for all of us in terms of what kind of impact in terms of jobs creation, in terms of the roles is it creating, and then I'll take you through the program that we offer at Great Learning very briefly towards the end. Hopefully everyone can hear me. If not, please drop a note and our team will work it out. Cool. Okay. So this is a question which I ask, people when I meet them for the first time, and then when we're talking about artificial intelligence, is that what do they envision when they hear the word artificial intelligence, right? It's a fairly broad term. People are using it now and utilizing this term for many things. But what does it mean? Right? And usually the answers that I get is are for, let's say, the first answer that I get usually is an image of a machine which is super intelligent, which kind of is similar to what we have been seeing in movies and like Terminator, etc., where smart humanoid machines who can also think and make decisions like us. So that's one of the responses which I get. Right. Some other responses which I get are of the driverless cars, right? And we have seen this technology evolve very rapidly in the past 5-6 years, right? It used to be something which people used to foresee would happen, but the kind of progress it has made in the last 3-4 years has been tremendous, right? We are now seeing working prototypes and also production cars which are very autonomous, right? So in some, and they're only limited by regulations at the moment. There are cars which can drive by themselves, but it's just that the regulations in some of the developed countries don't allow a car to be fully autonomous. And that's the reason they have, the systems are built in where a human driver will have to be present and will have to keep touching the steering wheel every now and then to tell the machine that to tell the car that a human driver is present, right? But for all practical purposes, we now have the technology wherein a car can self-navigate and all of that. So it's a really good example. So this is something that but still it remains very popular. One of the things when we talk about AI is that our understanding of AI is kind of impacted by some of these popular themes, right? So if I meet somebody who has a slightly more nuanced understanding of AI, right, the answer that I get is, let's say, an example of AlphaGo, right? So AlphaGo, so Go is a game which has been practiced for, it's a very complicated game, and it has it has like billions of combinations of moves which are possible. So now we have an AI which has beaten a human player, the human champion in the game of Go, right? If you remember, I think in the 90s, there was an algorithm which had beaten the chess players, the leading chess players at that point of time, right? But there has been a sea change since then. The kind of algorithm that was, which had beaten in chess versus this algorithm which has now beaten players in Go. These two algorithms are very, very different. In chess, the algorithm was just trying to predict the moves. It was just trying to predict or think 3 or 4 moves ahead. by looking at all permutations and combinations, right? So it was a very different kind of algorithm. With Go, what happens is, and it was more algorithmic. So when chess was, it was more rule based, the chess algorithm, right? So it was human intelligence which was codified into a machine, and then machine had the power to just compute all the permutation combinations and looking more steps ahead, more moves ahead than a human player. So it was a very different kind of algorithm. With Go, the algorithms have changed completely. So Go is powered by deep learning, is powered by artificial intelligence. Like what Go does is, the algorithm here, what AlphaGo does is it learns. So there are a lot of games which go into training this algorithm. So it learns from those games automatically. There is no human intelligence which is provided to this algorithm. You'll just play enough number of games and then understand from that what kind of patterns are emerging. How should it play the game? And from there, then it learned and then reached a point where it started beating, the top players in this game. So this is a sea change in the way intelligence is defined. I mean, this also is a good example to showcase how we have been defining intelligence, right? Earlier, it used to be something which we codify. We take our intelligence and codify into a machine. But now it is more about how we learn itself is now being codified, right? Again, a good example, a good analogy which I give here is, how a human child learns, right? So some of you may have children, right? I also have a son, right? And he is only 2 years old. But now, and he has started to speak now, right? But we never, went and told him about the grammar, about how to form sentences. It's just that he observed from all the conversations which were happening in the household, right? And then he learned automatically. So he just looked for patterns, and those patterns have given him the power to speak. And that speech is becoming better and better as we go along. So similar is the algorithms that we have developed now, right? And that's the reason we talk about algorithms like neural networks, right? The whole neural network, the term has come in because we have modeled the algorithm in a way the human brain functions. So these are the algorithms which are now and that's the kind of intelligence now which is developing, which is when we say AI, artificial intelligence, these are the kind of algorithms that we are talking about. Okay. So now let's understand even further what we mean when we say AI and what are the stages of AI. The first stage is narrow AI, which is a machine which learns enough to do one specific task well enough, right? So a good example is, let's say, in let's say image recognition, right? So humans have been, so one, and the other thing which has developed is the cognitive ability for algorithms. So earlier we used to talk about more task oriented things, and whatever was in the realm of cognitive understanding, like for example, looking at a photo and identifying which people are there in the photo, that is a cognitive skill that we associate more with humans because it requires a lot of context, it requires a lot of learning, right? But now, for example, Facebook has an algorithm called deep face, which can look at a photo and identify which people are there in the photo. So some of you who have been using Facebook for some years now, if you remember, if you go back 2-3 years, right, you would remember that when we used to upload photos to Facebook 2-3 years ago, it would ask us to tag those photos with which people are present in the photos, right? Nowadays, it doesn't ask us to do that. It automatically recognizes people in the photo, and whatever tagging that we had done provided for the learning for this algorithm. So algorithm learned using that data, and now it has become proficient enough to start matching human level accuracy. So this algorithm accuracy is now 99.14%, while human accuracy is just tagged ahead at 99.30%. Right? So now we are seeing algorithms which are mirroring human level accuracy. But when we say narrow AI, it is more about doing a specific task and doing it well. The second stage of AI is general AI, right? And the example here are more, let's say, your voice assistants like Alexa, Siri, or Google Assistant, right? So wherein you can talk to your voice assistant and ask that voice assistant a plethora of things. You can ask it about the weather, about a score for a game. You can ask it to set an alarm, right? And lately, you can also ask follow-up questions to the algorithm. So if you say something in some context, ask a question in some context, and follow up another question, the algorithm will retain the context. It will know exactly what context are you talking about, right? So this is more, so these algorithms are more purpose to handle a variety of tasks and interlink knowledge from one domain to another, right? So that was the example. That is the second stage, which is general AI. And the third stage of AI is super AI, right? And which kind of now goes into the realm of science fiction, because right now we don't have algorithms which can be categorized as super AI. But what super AI means is that machines which are sentient, which have their own intelligence, which have their context, right? Which can act independently and are inherently smarter than humans, right? Because once you impart intelligence to machines, right? The kind of data that they can access, the kind of memory that they have, the kind of things that they can link, even now far exceeds that of a human. So if you add intelligence on top of that, then these machines become smarter than humans. So this is on the horizon. Nobody knows what's the timeline to this, right? And this is now going to the realms of, but right now nothing like this exists, and it is now going to the realms of science fiction and movies like Terminator, etc. So I just want to quote Andrew Ng here. So Andrew Ng, as you all know, is a leading researcher and faculty in AI and machine learning across the world. So his quote is, "I worry about super AI in the same way that I worry about overpopulation of Mars." Right. So from this quote, we can understand that this is a very far-fetched idea at the moment. Right. Although from the recent trends, what we observed is that whenever we think of an idea as far-fetched, we have been surprised, and ideas have come to fruition much sooner than we ever thought they would. For example, the voice assistant. Uh, you know, these days there's a voice assistant in all of our pockets. In our phones, in terms of either Google Assistant or Siri, it is there for all of us to access. But the whole idea about voice assistant or a coherent product, which was demoed, was only in 2016, right, in Google I/O conference. So within 3 years from being just an idea, this kind of technology is now ubiquitous. It just resides with everyone. We can access it, right? It is deployed at production scale and all of that, right? And it is very accurate as well, right? Similarly, let's say when I heard personally of Amazon Go stores. So I'm not sure how many of you are familiar with Amazon Go stores, but Amazon Go stores are essentially stores which are cashierless. So again, the idea was coined in, I think, 2 years ago. And the idea was that you can just walk in to a store, pick anything from the shelf, and then just walk out, and you'll be automatically billed, right? And imagine the kind of accuracy you need to have, the kind of algorithms at play to be able to decipher what have you bought, right? And the accuracy that you need to correctly bill the customer, right? Because if you go wrong with billing, no product like this can ever succeed. You cannot be billing customers with wrong amount, right? So I thought personally, when the whole idea was coined 2 years ago, that it will take another 5-6 years for it to be implemented, right? But I was surprised, and many people were, that within 2 years, late last year, Amazon actually opened some of these stores in San Francisco, in the Silicon Valley area of the United States, in San Francisco and San Diego and LA, right? So we are now constantly being challenged on how much can we think, how far ahead can we think, right? And whatever we think is going to take X amount of time is now happening much sooner. So yeah, so it does, super AI does seem like a thing of a future, but again, we may be surprised and it may just happen much sooner. Right? Cool. So from that context on what is AI and what are the stages of AI, let's also try to understand some of these terms which are now used by everyone. And there is a lot of overlap in these terms, right? Everyone is talking about artificial intelligence, everyone is talking about machine learning, about deep learning, right? But I'm not sure whether everyone knows about what is the distinction between using AI or machine learning or deep learning. Okay, so AI basically is the umbrella term for anything which a machine does, which can be termed as intelligent, right? So anything where it is independent and taking its own decisions can be called as artificial intelligence. It can be very rudimentary. It can be rule based as well, right? Even if you, let's say, um, you know, program your microwave for, for like to run differently for different kind of food, that also is intelligence, right? Automatically if it runs. So it can be very rudimentary, but any kind of behavior which a machine is displaying, which does task in an automated fashion, where some calls have to be taken and the machine is taking it independently, that is coined as artificial intelligence. Within that realm, right, there's a subset of that which is machine learning. So machines which are powered by ML algorithms, so data science algorithms, which are slightly more complex kind of algorithms, right, which involve an element of learning, right? And by learning, what I mean is that if you run these algorithms multiple number of times, with every run, these algorithms will become better and better, right? So there's a learning loop, there's a feedback loop. So what the algorithm does is it looks at the output it is producing, the output which is desired, understands from what is the difference there, and then self-corrects to improve its output as it goes along. Okay, so that is all machine learning. So all of these concepts of random forest, unsupervised learning, supervised learning, ensemble techniques, right? All of these techniques are used under this umbrella of machine learning. And a lot of organizations use machine learning techniques to make their business decisions. And business decisions can be, let's say, forecasting sales or figuring out who to go and do who to market, or should they enter a particular market or not. In all of these business use cases, nowadays what organizations use are fairly advanced machine learning techniques. Right, gone are the days where there used to be only one ad targeted at everyone in a newspaper or on a TV channel. Right, now when you go to the web, every one of you gets personalized ads based on what kind of sites had you visited before. Right, all of that information is collected, algorithms are run on that, machine learning algorithms are run on that, and then a very specific, for a segment, very specific types of ads are run. So, I mean, now as we go along, it's not a choice for any business to not use machine learning. Like they have to retain their competitive edge. Everyone is running these machine learning algorithms, right? But the thing with machine learning is that, and in business scenarios, in most business scenarios, an accuracy of 60 or 70% is acceptable, right? So if you want to target uh, some population for your marketing and then decide which marketing campaign to run, even if you're going off by 20-30%, that is fine, right? As long as your most of your population is the target audience. So that's the reason machine learning techniques are now widely being used in all business decisions where 60 to 70% accuracy is acceptable, right? And actually, if it goes beyond 70, beyond let's say 80-85%, people often worry about that the algorithm is overfitting, right? And all of these concepts are covered in the course, and as you learn about machine learning, you learn about these concepts, right? But that's how it is. That 60-70% accuracy is when machine learning algorithms are used. Now, what is deep learning? So now when you want these accuracy to go higher from 60-70% to, let's say, 99% plus, right? And that's a big jump. The kind of techniques that you start using are very, very different. And all of those techniques are grouped under the term deep learning. So I described to you the example of Amazon Go stores, right? There you cannot live with a 70% accuracy. You cannot be billing 7 customers right and 3 customers wrongly, right? Because that's the perception that will build around wrong billing will build up, and then your model will never succeed. Or if you're doing image recognition, you cannot be okay with 7 people being identified correctly and 3 people not being identified correctly, right? So in some of these business scenarios, in some of these use cases, you need very, very high accuracy, upwards of 99%. And that's where you start using the deep structured learning algorithms, right? And this whole broad family of techniques are grouped under deep learning. So that's the difference. So to summarize, I mean, that was the difference between artificial intelligence, machine learning, and deep learning. Artificial intelligence being the broad umbrella for any machine to do a specific task under a specific context. Machine learning, so slightly more advanced techniques, which give about 60, 70, 80% accuracy. And from there, if you want to go to 99% accuracy and above, then you have to start using deep learning techniques, which are, again, you have heard about it, neural networks, convoluted neural networks, all of that, right? So some of these form the techniques used in deep learning. And so these techniques are now called deep learning. Okay. So this section was, the previous section was more about understanding what is AI, right? And just getting a little more sense on what is being talked about and what is the distinction between some of these terms, right? In this section, we'll talk about how does it apply to us? How does it apply to the companies? How does it change how the overall environment around us is changing, right? And how does it translate into jobs and opportunities, right? So in this slide, what we see is a path, right, from business intelligence. And this is the path which every company will have to follow, right, in the whole journey towards AI. So back in the 90s, most companies were using data and visualizing the data. And most of these companies were doing it not because they wanted to do it, but because there was a regulation. They were required to do it by regulation, right? So for example, let's say putting the data together for financial statements, banks would, reporting their risk metrics to the regulators, right? Pharma companies were reporting some of their test metrics, right? So they were just gathering data, and the max they were going was just doing visualization of data, and then, like, obviously all of us have seen the trend charts and pie charts, just very, very basic visualization to understand what is happening, right? Just figuring out sales forecast, is it increasing, decreasing? So all of that is clubbed under business intelligence, right? And they got more and more sophisticated. They started using some of these sophisticated tools to do it in a better way. But the whole essence was to just look at the data and understand if there are any patterns in the data. So that used to be in the 90s for most organizations. But as they moved along, the second stage was using that data to do predictions. So people started building uh, very simple kind of models with this data, just looking at a trend and projecting it 3 years down the line. So all of these small prediction modeling which started happening, which also at that point of time involved, let's say, regression, logistic regression, all of that. So all of that started happening in the early 2000s, which are termed under analytics and predictive modeling, right? And then after that, as the cost of storing data declined rapidly, and also the cost of computation became much cheaper. And as we saw that most organizations were starting to, the IT systems became more complex, all of that, they started gathering a lot of data, right? Now to process that data, the whole concept, first of all, to structure the data and store the data, the whole concept of big data came into play, right? And then as recently as 5-6 years ago, people just figuring out on using Hadoop and data lakes, etc., to store their data, right? But with the advent of such large volume of data, also then there was a need to use more sophisticated techniques which were more efficient in handling this kind of data. And those techniques then were called data science, right? And then from there, companies have moved to using machine learning techniques. And for some use cases now, a lot of companies have started using AI and deep learning. So this is the way, this is the data maturity and adoption in companies. This is the way it happens in each company. And any company that you think of is lying somewhere or the other in this path, right? And right now, most of the companies are at least between data science and machine learning, right? And many others have crossing machine learning point, and then they are moving towards utilizing more deep learning techniques, right? But even then, even if a company is not developed to such an extent, right, it is the next logical step for that company. So every company will have to go through this cycle, will have to, through this path, will have to develop and use more and more sophisticated techniques as they go along, right? Because as I was saying, it is not an option anymore in this competitive world, right? And the kind of use cases that we are seeing right now, which are enabled through some of these advanced techniques. For example, I used to work at a bank called Capital One. It's the fifth largest bank in the US, and I used to be a director there. And I had, a team, and my focus was more risk and operations. And I was leading a team of data scientists, etc. there, right? So within my previous role, I was working on a use case where we were using, we were trying to optimize our customer care spend, call center spend. And what we were trying to do was using natural language processing, NLP, which is a deep learning technique. We would figure out and also utilize understanding exactly, what kind of activity has a customer done before calling us, right? So basically, the idea is that people have issues, and then that's the reason they call customer care for an easy resolution, right? So we try to understand and try to predict that what could be the reason before they called us. If they called us, what could be the reason that this guy is calling us? And using some of the initial sentences, we then deciphered and we changed the IVR menu so that the first two options would closely match what's the reason this guy is calling for, right? And then what we realized was in 60% of the cases where this guy would have otherwise moved to speaking with an agent, the query was resolved in a much shorter time and with no cost because we had the solution ready for that customer. Right? So some of these use cases. So many companies, many businesses have these customer care centers and call centers, right? So now imagine some of these use cases becoming more popular and every company utilizing it. They have to, right? Because if the competitor is able to cut their customer care center by cost by half, and if they're not able to, then they will lose the competitive edge. So this is a particular specific use case which I worked on using deep learning, but it's a good example on why would every company have to go through this journey and start adopting some of these advanced techniques, right? And what it means is that the jobs creation in machine learning and in AI and deep learning will happen. First of all, it has been happening at a very healthy rate right now. So in the last 5 years, we have seen 5x growth in jobs for AI, right? And NASSCOM predicted that in 2018, last year, that we have created 100,000 jobs in machine learning and AI in India itself, right? So we have seen that. We've seen very healthy demand for machine learning and AI. But as we go along, this demand is going to become higher and higher and higher, right? Because of some of these rapid developments in use cases and companies' adoption, right, of some of these techniques. Okay, so this is a slide which just summarizes exactly what kind of trends are emerging in AI, right? I want to, I talked about the bottom right corner, which is 4.5x growth in jobs requiring AI skills since 2013. In the 5 years since 2013, we have seen 5x growth, right? The other thing which I want to point out here is the error rate, which is the middle left in the adjacent box, has gone down from 28.5% in 2010, and in 7 years it has gone down to 2.5%, right? And for Facebook deepface, that is now in 2018, it was only 83 basis points, right? So now with this kind of a drastic improvement in the algorithms, a lot of use cases which, as I was describing, some of these, you cannot go to market with a 30% error rate in some of the use cases, but you can definitely go to market with 80 basis points error rate. Some of these use cases are now becoming more and more mainstream, right? And can now be applied to variety of business problems. So then that is what is fueling this growth in demand for AI and creating a lot of jobs in AI. Right. The other thing which I want to point out here is that 84% of companies have already invested in AI. I mean, that's a staggering number, right? 84%. And I was surprised when I looked at this number, because from our popular perception, from talking between us, from our between a peer group, among a peer group, right, the sense that we would have here would be of a lower number, but 84% is staggering, right? I mean, that's so we do see that momentum building towards more jobs and more demand for AI, and we've already seen that happening, but this momentum is building to get more and more of these jobs created as we go along, right? And these are some of the charts which make the same point which I was making, that if you look at the trend of AI course enrollment, that has just picked up beginning, let's say 2014, you see a dramatic change in the slope, right? And that's where some of these use cases are becoming more and more production ready. If you look at ML course enrollment, the chart picks up a little more earlier. It picks up from 2012, right? Because as I said, machine learning has been fairly pervasive now, and I think some of these guys, some of you who are in service sector would also have realized within your work and the kind of projects that you're getting from your clients these days, right? That most of these projects are in the machine learning. There is a market shift in the kind of projects which are coming from some of these companies, right? And you would also, even otherwise, in your workplace, you would see that this is a kind of shift which is happening. Right? And if you break it down further, these are the skills which companies are looking for, which are machine learning, deep learning, and again we see that there's a growth since 2016, right? And it's just growing at a very amazing pace. And all of the skills which are in demand, machine learning, deep learning, natural language processing, computer vision, speech recognition, right? All of these skills are, first of all, within that realm of machine learning and AI skills. And these are all the skills which we also teach in our program and you will learn in the program. Right. The other indicator is GitHub stars, which basically is awarded to people who are contributing meaningfully to GitHub. And GitHub is a repository where some of the, especially professionals using machine learning and AI techniques, use as a platform to showcase the kind of work that they're doing, right? And what we see is that TensorFlow, which is a library used for more deep learning algorithms, and scikit-learn is a Python library which is used for machine learning algorithms, right? We see a much more rapid trend or increase in TensorFlow since 2016, almost starting from the same level, right? We see that TensorFlow is now growing, and obviously the machine learning algorithms also are growing, right? And by the way, GitHub, in our program, we also use GitHub, because the idea is that whatever you do in the program, so during the program, what each participant gets to do with us is to work with a lot of projects and lab exercises, right? And all of these are based on or simulate some of the business situations, and all of the algorithms that you apply. You can get a sense of how do you apply that in your business. But then all of these projects are submitted on GitHub, and Then each participant builds a repository of projects that he has done on GitHub, which can be used to showcase the kind of experience, the kind of learning each participant has. Right? And what you observed is, for this technical community, for community which is working on ML and AI, that's the kind of trend we also see for, let's say, for job applications or interviews, where people expect to look at your published work. And this is a market change from the previous kind of skills, that how the skills were assessed, right? I mean, earlier there used to be a lot of in-person interaction and talking about your experience and all of that. Right? Today, the whole shift is towards show me what have you learned, show me what have you worked on, what kind of projects have you worked on, right? And let's discuss on the specifics of that project. So having that GitHub repository helps in showcasing very easily, even on the LinkedIn, right, the kind of projects that you have worked on and the kind of knowledge that you have in these areas, right? And the other point is that, this AI story is not just panning out in the US or in the developed markets. It is equally panning out in India. Like in the last decade, the kind of service model that we have employed in India, right, with all of our top tech consulting companies catering to a lot of projects in the US, what it has ensured is that whatever developments are happening in the US, India is very, very close. The lag time of us adopting. Actually, if you look at the teams for the US companies which are working on machine learning and AI, what you'll find is that most of the teams are comprised of Indians and people from China. So it is us who are fueling that kind of growth in the US as well, right? And for that reason, the lag time has decreased, and we see a lot of demand for ML and AI skills in India itself because we are so closely tagged with the developed markets, right? So, this graphic also kind of points to the same theme where for companies that are based out of India, I mean, that is 22% are utilizing AI at the moment, but by mid 2019, right, this report by Intel predicts that it will go to 70%, and all the AI workload worldwide are and data centers are running, using AI. This is something which is specific to Intel. But the main thing to note here is that 22% Indian enterprises have already adopted AI, and within a short span of time, that number is going to grow very rapidly. Okay. So that was the end of the second section, which was just trying to give you an idea about the overall business environment and the kind of demand that we are seeing in terms of opportunities and jobs in the industry in ML and AI. Right. Let me now very quickly walk you through the program that we offer in artificial intelligence and machine learning. Right. So we offer two types of programs. Right. So first of all, we offer programs in machine learning and artificial intelligence. Right. And within these programs, we offer two types. One is blended, which is which is more in a classroom setting, and it is augmented by online content, right? So, and the other one is purely online, but the thing that we do is there is personalized mentoring. So at Great Learning, what we believe is that, first of all, ML and AI topics are fairly technical in nature, right? And I talk to a lot of people who try it on their own, and a lot of online courses without any support, and they're not able to latch onto the content because it is fairly technical in nature. And Great Learning, our belief has always been that learning with support, with some kind of support, with that support system, the support system is very, very important to get learning outcomes, right? And one metric that we really take pride in at Great Learning is that 90% of our students graduate from the program or pass the program, and they have their learning outcomes met, right? And the remaining 10% is not because they were not able to follow the course, it's because they probably go on site or have projects and all of that, right? But so we know that this kind of model really works. Unlike purely online, where the success rates, completion rates are only 20 to 30%, with guidance, with mentorship, and that's what we have designed our online program with. The completion rate, you have something to fall back on. You have a peer group to talk to. You have a mentor, right, who would be connected with you, and what we have seen is that people develop really good professional and personal relationship with this mentor as they go along. So they're all invested. It happens in a micro class. One mentor for 10 students. It's very, very personalized, right? So that was the online program that we offer. In the blended, which is more weekend classroom, obviously, if you're coming to a classroom and interacting with the faculty in the classroom, interacting with your peers in the classroom, that brings some other advantages and is a slightly different learning experience, right? So these are the two kind of modes that we offer it in. One is blended and one is online with personalized mentorship. Our AIML program is 12 months in duration, and our ML program, machine learning program, is 7 months, right? And why are these programs unique? From our point of view, hands-on. I think that again is very critical. Knowing about a particular topic is one thing, just reading about a topic, right? And these days, again, it is becoming very easy to just know something about, and just, know only something about these topics. And you can talk a little bit about it. But what we have seen is that with hands-on practice, and that's what we enforce in all of our programs, right? With hands-on practice, you become much and much clearer about exactly what is the kind of nitty-gritties involved. You have a better appreciation, right? And that's the reason candidates are able to practice it, and they're able to take it back to their companies and are able to do projects in the companies, right? And as I was saying, you also build a portfolio of projects which helps you in showcasing what you have done, right? So again, a lot of people who are just talking about some of these techniques without understanding in depth about what it means, and they will not be able to implement it. But that's the way, by hands-on practice and by building a portfolio of projects, our alumni and our students are able to differentiate themselves, because they can then talk about specific things that they have worked on, and the learning is much, much deeper because they do a lot of hands-on, right? So that was first theme. Second theme is industry focused. So our curriculum, so one thing that we need to understand here is that the kind of use cases that companies have using machine learning or AI are evolving very, very rapidly, right? If you look at use cases which existed, let's say 2 years ago, are very different from the use cases that are being deployed right now. I mean, look at the error rate, right? When we saw in the previous slide that the error rate has decreased so significantly. So a lot of new use cases have become playing field, right? Level playing field. So in these areas, the kind of examples, the kind of usages people have are changing very rapidly. So it's very important to be in step with what is happening in the industry. Right? You don't want to learn something which the industry was using 2 years ago. You want to learn things which are happening in the industry. And that's what we enable by using industry experts. So these industry experts, we do frequent review of our curriculum, and these industry experts co-develop the curriculum. Some of these industry experts also come. If it is in a blended program, they come in the classes to teach. If it is an online program, all of our mentors are experts in these areas, right? And they're working on some of these techniques in their work or in their research, right? And from their experience, and since you engage with some of these people who are working in the industry, they also share a lot of things that they have experienced themselves, the kind of anecdotes that they share, things which have gone well with them, not gone well for them, all of that happens, right? So then the learning is very, very rich with this, with having that, making sure that it is first of all very relevant in whatever is evolving in the industry, and by the interaction which happen between the industry professionals and the candidates, the learning is very relevant, right? And current. So whatever you work on is all the case studies or the examples that we pick are things which are utilized in the industry, which are pertinent today, and also looking a little ahead, right, which are evolving and emerging. So what you build is something which is very exciting. If the kind of projects our students end up doing, right? And we have a capstone project at the end of the course, and we let our students choose the capstone project, right? So they can go and choose any kind of problem they want to solve. And what we help them with is defining the scope of the problem, defining the approach, and all of that, right? But but with that, you can build a portfolio of projects that you of the problems that you want to solve, right? That are very evolving and contemporary. So with these three things, what we make sure is that the learning outcomes, what people get at the end of the program, are really good learning outcomes, right? And that also translates into really good career outcomes for our students and alumni. Okay. And we cover all the techniques which are being used in machine learning and AI. All of them are covered in the course, right? So deep learning, neural networks, right? We use Python. Python is the language of choice for, especially for AI algorithms, right? TensorFlow, etc. are developed in Python. We cover all the basics. Plus, we don't need you to be proficient in Python. During the course, we ensure that you build a base in Python and then start using it. So there is no expectation for you to coming into the course for you to have prior understanding of Python, right? And the other thing is, focus is, in addition to having theoretical concepts covered, but so that you have a good appreciation and understanding of all of these techniques, the focus is also, and actually more, on making sure that these are married to the applications, right, to your business understanding, so that you can use these techniques to solve real business problems. So this is more a practitioner's perspective that we provide. And then you have a portfolio of 12 plus industry projects. This is the structure of the program, right? We start a little slow by building a base in Python and stats. Then we go and cover the machine learning techniques. And in the AI, we cover all the relevant use cases in deep learning using neural networks, which are computer vision, NLP, intelligent agents, etc. Right? And the AI part of the course has been created by IIT Bombay professors for us. Right? Again, there's some examples of the kind of projects which our students have done. Looking at, let's say, New York City's taxi supply, looking at data from Uber, right? Some of these problems which the company still, Uber is trying to solve, and the kind of evolving problems is what we usually do as capstone. Looking at customer sentiment from Amazon reviews, like all of this. So just gives examples on how our projects are structured, and they're always on the cutting edge, on the things that contemporary problems which the industry is also trying to solve, right? So these are the prerequisites for the program. And I get a lot of question on this, that do we need to know Python? Do we need to know programming before signing up for this course? The simple answer there is, as long as you're not scared of programming, right, then you are good. Because whatever you need to know, and Python is a very easy language to learn, right? It's unlike like C, C++, where you have to write lines and lines of codes. Python is a very condensed language with like 2-3 lines of code. You can run a neural network, right? So it's very, very easy, user-friendly and easy to use and very easy to learn, right? So you don't need to know, but you should definitely not be scared from writing some lines of codes, right? So that's the prerequisite of the program, right? And these are some of the other things that we do to ensure there is a career success for each of our participants. So we do a lot of career development workshops, right, where we talk about more about emerging trends, what kind of roles can you look to apply for, what kind of roles exist, right, what kind of transitions people have made, what kind of skills do you need to have, all of this, right? Industry connect through mentors, through a lot of, we also do career fairs at regular intervals every month. Last career fair we did was in Chennai, where about 20 companies came in on the same day, and about 200 alumni attended that career fair, and 140 of them got, further letters of intent from that process. So we keep doing it, and all our alumni and students are invited to all of these career fairs, right? Peer-to-peer networking. We keep publishing opportunities, lateral opportunities on our Accelerate platform, right? So all of this ecosystem, this support system also is in place to help you once you have achieved learning outcome to also help you get the career outcome for yourself. Okay. And if you look at this list where our alumni work, what you realize is that now, and this is only an indicative list, right? I'm guessing any major organization, we have our alumni working there, and that too at a fairly, mid to senior role in ML and AI domains, right? And what you'll see here is that the companies listed here are not limited to only some domains. And it's like 10 years ago, it used to be only big technology companies like Amazon, Facebook, Google, right? But now you see things, companies like Royal Enfield, right? Taj, Apollo Hospitals. So across sectors, now there are opportunities in machine learning and AI, which are across sectors. And as I was talking about, this is more a broad-based opportunity which is evolving, right? And the kind of analogy which I take here is, if you go back to 1990s, right, when the whole IT revolution happened, it started with only a few companies, but within 5-6 years, every company was utilizing it, and now you cannot imagine a company which is not utilizing complex IT systems. Similarly, for this, within 10 years, it will be unimaginable for any company not using machine learning or AI. So that was all from me. Let me just see if there are any questions. Okay, let me just quickly go through some of the questions. Yeah, so one question is, if you go to 99% accuracy with deep learning, does it not overfit? Right. So there are the way this deep learning techniques are defined, the algorithms are defined, are very centered on the outcome that they have. So that ensures that there's no overfitting there. Right. And this is some of these details you will learn in the program. Right. Can I understand that DL is the enhanced model of ML? I think DL and ML techniques are fairly different techniques. Right. And I described that DL is a very different, when you have to go from 70% to 99%, that's where you start using DL techniques. Okay. Is machine learning helpful for DevOps guys? Yes, why not? Actually, a lot of our alumni come from this background, and we have seen that all of these guys have been able to either have a better role in their own companies, or they've been able to make those career transitions for themselves. Right. AI spent with 2021 is data specific to India? No, I think that was worldwide. What is the acceptability of this program in Indian job market? As I was saying, in all major companies, right? Our alumni are working in all major companies. And what we have realized is, first of all, I mean, there is definitely an understanding in the industry, and the cognizance in the industry on the program that we are running, right? But above all, what has started happening is the focus on the certificate and there's more focus now on the learning. If you are able to demonstrate to anybody that you know about these techniques, that is what companies are looking for. So definitely there is a recognition for our certificate, right? Definitely it does help you get that foot in the door and that conversation going. But at the end of it, what it boils down to is showcasing what have you learned, right? And learning outcomes are very, very important. The bunch of questions around from different fields switching to AI and ML. I think the short answer there is that for all domains, AI and ML techniques are going to disrupt a lot of domains, a lot of companies, most all, right? I mean, things like taxis, hotels, right, content, all of these domains have already been disrupted by AI and ML, right? And then banking, etc. Now companies are working hard to disrupt some of these traditional strongholds of highly regulated industry sectors, right, where it's not very easy to make inroads. So as we go along, this will disrupt almost every sector and company, and then it's from whatever background you're coming from, right? You can always marry this understanding with that background. You can always position yourself for a better role, right, and a better career outcome. Is the online course time specific? The way we run our online courses, as I said, it is coupled directly with, so it is enabled with personalized mentoring. So what we do is there is content which is shared with you on a weekly basis. We're supposed to, the only discipline that we need from you is to consume the 2 to 3 hours of content, video content you have to consume, and then there's a week, on the weekend there's a mentoring session. You have to come prepared for that, and that, so then it is basically on in that week it's all flexible for you. How do you want to structure it? How do you want to consume the 2 to 3 hours of content? Right? Mentorship sessions happen at particular time slots, but then you can choose a time slot and then get according to your availability. In terms of online course, do we just watch the videos and learn? No, I think the way it is different is that there is personalized mentorship. So every week you get to meet a mentor, and that mentor, it's only a group of 10 people to one mentor, right? So you have a very one-on-one, and then you meet the same mentor week on week on week for the whole year. So then the mentor starts understanding what kind of things that you need, that you, right? And whenever you're getting stuck, you can reach out to the mentor. So that's the reason, having that support system, that unique support system in terms of that mentor being there, and obviously the team here at Great Learning in terms of technical experts who are there to help you, right? So I think that is what we, in our view, makes a lot of difference in learning outcomes. And that's the reason it is, the course that we offer is not comparable to any online course. Online courses, as I said, have completion rates of only 20 to 30%. Our courses have completion rates of 90% plus, which is staggeringly, it's very different from how the other players in the industry work. In the interest of time, let me just see if there's any other interesting question. The other theme of questions is more on, hey, I have 10 plus years of experience, I have 12 plus years of experience. Would this course help me on how, what kind of career outcomes can I look at if I have already have 10 years of experience, right? So in interaction with the industry, what we realize is, as they're moving towards more machine learning and AI themes and projects, right? They need leaders. They need people who, they need leaders to lead these projects, right? So people, they're looking for people who are seasoned in leading big teams, who are seasoned in managing clients and all of that, right? To lead some of these themes and projects. And there's a lot of scarcity in the market in terms of experience and knowing about machine learning and AI. And so we see, when we talk to the companies, what we realize is they are really struggling to find top talent in these areas with a good demonstrated experience of, business impact and business outcome. So when you marry that, your rich years of experience with these techniques, right, then it becomes really powerful, and actually companies want to hire that kind of talent. So that's the reason, if you have a lot of years of experience, right, but if you have, let's say, if you've been managing teams, managing clients, managing business verticals, outcomes, all of that plus machine learning makes it much more powerful. Right, I think that's, I'm just going through the other questions. I think every other question is more or less on the same lines, right? If you have further queries about the program structure or anything that you want to discuss specific to your case, please reach out to our admissions team. We'd be really glad to talk to you one-on-one and help you. Thank you all for taking this time and then coming and attending this webinar. It was really my pleasure to have interacted with you today. Thank you.